Today we're going to pick back up with graphing quadratic functions. Again, I just want to review what is a quadratic function. It's written in the form ax squared plus bx plus c, and a cannot be 0 because then that would get rid of this term and then it would just be a linear function. And this is the linear term. This is the constant term. Again, just like in slope-intercept form, the constant out here, it would be y equals mx plus b, and not when it's written in that form, but it's still the constant. This constant is the y-intercept. But one thing to watch out for, don't think that this b is the slope of our line, because it's not. We don't have a straight line when we're graphing a quadratic function. We are going to have a curved line. So make sure to look out for that. Let's jump in to look at some of these examples that we have not covered yet. Let's see if it'll let me scroll over here. We've looked at the example of graphing them, so now let's kind of compare some quadratic functions. Again, remember that a value tells us if it's a happy face, that a value could tell us if it's a frowny face. When a is positive, it's going to open upward. So right off the bat, I know by looking at this that my a value is negative. I know that there's a y-intercept of, it looks like, -1, -2, -3, probably -4. I also know that it crosses the x-axis here, so these are my solutions to this quadratic function, and we know that the vertex could be found here at 1, 2, 3, over 3 and up 1, 2, 3, 4, 5. So I know a lot of things about this function right now. So again, it says compare the graph of f of x to a quadratic function g of x with a y-intercept of -1 and a vertex at 1, 2, which has a greater maximum. Well, here, if my vertex is at 1, 2, then I know that the highest or lowest point on my function is that 2 value. Well, right here, this has a maximum of 1, 2, 3, 4, 5. So this has a greater maximum. This is the maximum value right here. So we can move through the slides to kind of see how to graph g of x using this given information. The vertex is at 1, 2, so we know the axis of symmetry passes through here. It has a y-intercept of 0, -1, so we also know we can flip that point across on the other side of the axis of symmetry. We draw in our line, and again, like I said, we can tell that this one has a higher maximum. It has a maximum of 5. This one only has a maximum value of 2. So f of x has the greater maximum value. Let's look at example 3 here. I just love quadratics. I just think it's so cool how you can look at the equation and get so much information. I don't know. I'm probably weird, but that's just me. A ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate that for each $5 increase, they will sell 20 fewer holiday weekend passes. So they're wanting to maximize their profit. You know, that's what every business wants to do, right? Get the most money that they possibly can. So there's a give and take here. They're raising the price, so they're getting $5 more per ticket that they sell or per pass. However, they're going to sell to 20 fewer people. That's taking we got to figure it out. Are they going to take a loss? Well, think about that. They're getting $5 more, so they're going to be selling them for $125, but then they're going to sell 20 tickets less. So at that price, they're going to then sell them, they will probably sell 660 tickets instead. So we have to think about this. How much should they charge in order to maximize profit? Well, our first step is to define our variables. We're going to let X represent the number of $5 price increases, and P of X will then represent the total amount of money generated from the holiday weekend pass sales. P of X is equal to the price for each pass 120 plus 5 times X. That's the total number of passes sold, then would be 680 minus 20X. Again, the price was $120. They're going to increase that by $5 so many times. We don't know how many, but however many times they do that, that's why we let it be X. We also know that it's going to drop by $20. So 600 minus 20 for every $5 increase. So we can write our equation. Well, this is our equation. Now what we have to do is go ahead and factor that out. They did it for us. Remember the FOIL method? First times first, outside times outside, inside times inside, last term times the last term. And we end up with this. So we can simplify. Here is our quadratic equation. Notice my x squared term's coefficient is negative. So we know this is going to go like this. We can reorder it because I like it to be in this fashion. I'm sure you probably do too, because that's how we typically look at it. Now that we have this, we can go to Desmos and graph it, or we can find the axis of symmetry by doing the negative b, the opposite of this coefficient, divided by 2 times a. Well, a negative divided by a negative is going to be a positive, so I know it comes out to be a positive number. So when I plug in negative 1,000 divided by negative 200, I get out a positive 5. Now we can find, that is our x value. To find the y, we're going to take this 5 and we're going to plug it back in place of x. Now be careful when you do this. You can find the vertex by using the graphing calculator, or you can go to Desmos and do it. Just be careful when you type it into Desmos that you type it in exactly the way that it was written. Let's see, graphing calculator. We had y equals. I always recommend, I'm all over the place here, doing this on Desmos if you're allowed, because then you can make sure that you have the correct answer. I would do it algebraically, but then I would double check myself if I had the opportunity using Desmos. 100 x squared was next, plus 1,000x plus minus, I can't remember, plus 81,600, plus 81,600. Okay, so we're definitely going to want to zoom way, 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 way out. And look, when I come up here, we can find the vertex. Zoom, 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 zoom. It's way, way up here. 5 squared times 100 is plus 5,000 plus 81,000. That's going to be a really big number. Let's keep on going way up here. Way, 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 way up here. Way up here. Maybe we'll find it. Maybe we won't. There it is. So now we'll zoom back in now that I'm back here so that we can find what the coordinates are of this vertex. There it is. My x is 5. My y is 84,100. It's pretty crazy. It's a pretty big number. But it makes sense because this is 81,000, so we're adding all of that. Well, we are subtracting this part, but we're adding 5,000 and then subtracting a number. So anyway, makes sense that that would be the correct answer. So let's go back over here and look. Interpreting the results. So what does that mean? Well, we're trying to maximize the profit. Think back to what we were looking for. If we're maximizing the profit, we're wanting to know how many tickets should I sell to get the most profit? Well, or how many price changes can we have? This X represented the number of price changes. When X is 5, that tells me the most amount of money that I'm going to get. This is my total cost. So after 5 price changes, that means we're going to change up the price $5 5 times. So we're going to be charging, instead of $120, we're going to charge 5 times 5 is 25. 120 plus 25 is $145. So we know that we're going to sell 20 fewer tickets for each of those, but that's still going to give us a maximum profit of $84,100. That's pretty cool. So again, my domain is X's from 0 up to 34 because the number of price increases cannot be negative. So if we look back, if I was to zoom way back out here, scroll down, scroll down, scroll down, scroll down. Looking at this graph, I wish there was a better way to do this. I'm sure there is, and I'm just not smart enough to do it, to know what it is. You guys probably all know, and I don't. If I scroll out, here we go. There it is. Look at this point right here, 34. We're only wanting to look at the numbers from 0 to 34. Yes, all of this is part of my graph, but it wouldn't make sense to have answers down here in the negative. So that's why it's telling me my X values are between 0 and 34. Therefore, my Y values are also between 0 and 84,100 because we can't have a negative amount of prices. So we can have 5 ticket price changes and get our maximum profit. All right. I'm going to stop there. That kind of takes care of what I was hoping to cover today, what I was hoping for you to learn. I hope all this made sense. Again, we'll try some problems in class this week. And if you have any questions, make sure to join me virtually. See ya.